Thank you so much for joining us here in this inaugural session. We have with us Dr. Jaykumar Vaitishankar, who will be the initial few days Dr. Jaykumar will be taking, and he is one of the person who does a lot of programming sessions on Qiskit and other tools. He's there, and Dr. Ashwath Babu is there from IIIT Dharwad.
Hello.
And Dr. Mustafizur Rahman, he is presently in Japan as a research collaboration. He's part of IBM Quantum Research, Dr. Mustafizur. Without wasting much time, there are 300 participants. I'll request Professor Madhumurthy sir to share a few thoughts about the program, about the vision, and also interesting things are happening in state government of AP. Hackathons happened, and we are waiting for the final round. So a lot of things happening there, and it's not only for AP. We can see that the participants across the country are participating. So I think maybe I'll give request Professor Madhumurthy sir. Professor Madhumurthy sir is HAG professor from NIT Warangal, presently holding the position of the chairman of the AP State Council for Higher Education. It is a similar body which is similar to AICT for us. For the government of Andhra Pradesh, APSCHE does the same work. It combines universities and engineering colleges and all the institutions actually under that. So Professor Madhumurthy from AP State Council for Higher Education. Over to you, sir. Mute karna.
Thank you, Professor Emmanuel Subakar. And a very good afternoon to all the members who have joined, the experts who are going to handle the session. One moment, please. Can I just join? I'll just join a moment, Subhakarji. Yeah, good afternoon to you all. There is some mess happening here. Well, let's ignore that. We started on a very positive note, this faculty development program. And it was the energy of Professor Emmanuel Subakar that has made all this possible, with the support of industry and, of course, with the hand-holding of National Quantum Mission. You know, we had the support of Venkat Subramanian from IBM and Dr. Sridhar from TCS, and of course, with the blessings of Anil Prabhakar. And we also hope that we would have some more people with the startups joining, supporting us. As Professor was mentioning, I think we are entering a phase where we had basic fundamentals reviewed or refreshed, and now entering into programming and a hands-on sort of entry into the quantum technologies part of it. Probably the hardware is something not very much possible online exposure, but I think we are going to have some sessions on programming, simulation, and quantum machine learning. In fact, an exposure to the quantum computers and cloud-based quantum computers and the type of errors that we are likely to come across. And with this, some of the industry-related perspectives are also likely to be introduced at this particular point of. Let me tell you what's happening at the Andhra Pradesh Center. We had Dr. JBV Reddy and also Dr. Sridhar visiting us on Saturday. We had a meeting, a very important meeting here regarding further exposure of about 50,000 people to quantum technologies. We wanted to offer this particular program of creating awareness amongst the younger generation, the students, and the target that we set for ourselves is to meet 50,000 people. And immediately, as we understand, there's a program by Wiser starting off on 5th of November. Okay, it's a 10 days program which is free for all from 5th to 15th. But Wiser is likely to come up with a program which is very specific to the needs of our faculty also from somewhere during December. In addition to this, how we wish to meet this grand requirement, a large requirement of awareness being created is also through NPTEL and SWAYAM. Sometime in January, February, very soon after the reopening of the institutions, we are likely to come up with a program from SWAYAM on the NPTEL platform as well. That we hope would probably expose, and people who would like to be certified would also be benefited through a payment of about 500 rupees. It's not a fully free program, but voluntarily people could participate. If they do not need certification, they could go ahead. As Professor Emmanuel was mentioning, the bubbling enthusiasm that has been shown by the youngsters during the Amravati Quantum Valley Hackathon 2025 that was held till we completed the semi-finals round, and there were close to about the boot camps that we did had participation of more than 20,000 people. That's the sort of enthusiasm, and close to about 3,000 teams participating all across, not only in Andhra Pradesh, but also representation from the neighboring states as well. For example, there were also teams that came from Maharashtra and Rajasthan. So, not just the neighboring states. So the enthusiasm is all across, and we are surprised to see that within a very short period of about, say, 2-3 months time, probably not much more, it has become a street talk. Quantum has become a street talk now. That's the sort of awareness that has been built. And the book Quantum Nation, which was also translated into Telugu, has been having a great sale here. And some of the other popular books are not really readily available in the bookstores. That's the sort of a trend that's happening, and youngsters are very enthusiastic about all this. Very soon, we are likely to have the final of the hackathon. Most probably, would our Honorable Chief Minister Chandrababu Naidu Garu might grace the occasion along with our Minister for Human Resource Development, Sri Nara Lokesh Garu. That is quite likely to be in the coming 3 weeks. Let me also tell you, we have an idea. The State Council for Higher Education at Andhra Pradesh is planning to come up with a portal where we would like to host the quantum algorithms on the portal. We wish to have a repository on the quantum algorithms and some of the problem statements that have come through. And, we wish to update this on what's happening in the quantum areas. Most probably that would also be launched by during the quantum hackathon finals. Along with this, there is also enthusiasm built within the students and the faculty that one of our team has come up with an AI tutor, which would be an AI assistant, teacher assistant, which would help all the slow learners, by which we mean we are all slow learners. Okay, so it is meant for all, and it would be an assistant for the teacher as well as for a friend by the side for the students to guide them, a mentor them on the subjects that they are going through. I think this is one new addition, which was a confidential project going behind the scene, and we wish to launch that along with this during the Hackathon Valley. I think that would also help students to learn more on what quantum is, because this hackathon that we conducted, before that, except for the boot camps that we did, there was absolutely no exposure that was given to the students. not like the theory subjects that we have and the number of courses that we have been covering. But the enthusiasm is something unbelievable. The challenges, I think the classwork that we have been dealing with doesn't seem to be challenging the students. I think they found something to find on their own and to resolve or to come out with some solutions for the problem statements that we gave them seems to be the most encouraging part. I hope in times to come, the assessment and evaluation of our own coursework, even for the degree or certification programs, would be something application oriented, so that they would much better prepare the future ready category of students. With this, I wish all the members who have registered for this QT-04 program to have a nice time, probably some hands-on sort of an experience with respect to the quantum technologies. I wish you a great time and wish you all the best. Thank you, Professor Emmanuel Subhakar, for giving us and hand-holding. I should thank MNIT Jaipur and the administration who had been supporting with the assistance of MIT for all these programs for us to be exposed to such technologies. Thank you so much.
Thank you. Thank you very much, sir. Thank you very much. Yeah, thank you, sir. Last program, we had about 750 faculty members from AP State and another 150
Wonderful.
Programs otherwise. I think 250 otherwise. Total, we had 1,999 participants, sir. About 915 or something qualified for the certificate also. We'll be issuing today by evening. So that was a great this thing, because earlier it was 600, now it has become 750, and I hope the numbers will increase. So at this time, I'll request Dr. Mustafizur to share first, then Dr. Ashwath to add, and then Dr. Anil Kumar to share also from AP State Council for Higher Education. If he has some network issue, but in case he's able to share a few words. He's in SV University, Tirupati, so there is some network issue there. So let's hope he'll be able to join, speak. Otherwise, then lastly, Dr. Jaykumar will share. Maybe with that, we'll conclude the inaugural with Dr. Vikas sharing the vote of thanks. Then we'll start with the lecture by Dr. Jaykumar. So we'll start with Mustafizur, sir, then Dr. Ashwath, Dr. Anil.
Just a word before. Can I share some?
Please go ahead, sir.
For the benefit of the participants.
Sir.
One important thing here is, before the Quantum Valley gets established at Amaravati, we are also trying to identify 100 best students as well as faculty to be the users of this quantum facility, who would be trained specifically at facilities of IBM. Okay, so the race is on. We are looking for such people who are committed, who is interested, who would like to make best use of the facilities that are being created and continue to be with quantum. So I just wanted to share so that we also make up our mind, prepare ourselves for this. Thank you so much.
Thank you. Thank you so much, sir. Yeah, not only this 100, there will be so many opportunities because of the Quantum Valley.
After this first set of 100, there is a second set by TCS, another 100.
Correct.
Come up.
Yes.
There are several things. CDAC is coming up with another 100, and it's going to be a large number. One after the other. Yeah.
So the opportunities are there. Yeah. Thank you. Thank you so much, sir. Yeah. Dr. Mustafizur from IBM.
Yeah. Thank you, sir, for this kind invitation, sir. So my kind regards and my gratitude to first goes to my teachers, starting with my schools, college, and alma mater, IIT Kharagpur, and of course IBM and everyone here. Okay, and I'm really honored and really humbled that I'm part of this course. And every time I participate in this course, even 2 years back when I just finished my PhD, and then I was giving like some talks and all across various IITs and all, and then like Professor Ashok Babu is here and Jai Kumar, so they all know me. They will also share their experience. We also started recording for DST, then for this MNIT program, and now with the AP Council, the similar program. And every time I restart the course, so whenever Professor Pillai sir ask me to share the notes, I don't have anything because I restart learning. So it's like in Bengali we say bindur moddhe sindhu darshan, means looking the universe in a circle. So means we start the same thing but very differently every time. All the teachers we are also learning. And professionally, I'm not a teacher. So I'm just part of the IBM team, and I'm really fortunate that I can share my experiences and because of my fond in mathematics, so I am like I get some topics. I choose those topics to teach. And I feel like this is a really, really good opportunity because India is moving to a nation to lead the world, not only in the quantum but in most of the technology in upcoming era. And with the leadership of Narendra Modi ji and all everyone regarding this AICT, DST, and the states are right now contributing the AP Council, the AP state, and other state are also like contributing a lot. And IBM, it's a place who are like as part of the IBM, we always try to connect with the ecosystem. And this is really an honor that with this course we will be connecting to many participants. And I will request everyone to, of course, you will feel excited with this course through the programming or the previous course like the introduction and the upcoming course on quantum computing algorithms, communication, security, materials, and other things like QT-01 to probably QT-11. But I'll especially for the teachers and especially for the new scholars who are coming to quantum. So I'll request you to visit the others NPTEL lectures NPTEL and the MNIT lectures available on YouTube. You may contact Pillai sir because some of the materials are already available. You can look back what is already taught by Ashok Babu sir and Jai Kumar sir and other experts, and you can again come back what is already, because every time we update ourselves also, right? So the most important part is that we all are learning, and every time we come back we try to get that you are interested, you are motivated, and you are contributing to the nation. So that's all about this objective of the course. So thanks a lot for inviting me. And I am currently in Japan, so I got some invitations from Japan for some talks and all. So I'll be there in India next month, and I hope I'll be taking some part of the course. Yeah, thanks.
Thank you. Thank you so much, sir. And sir is with RIKEN, which is also a leading fond of quantum computer they are developing. So IBM is partnering with them. So he's there. So Dr. Ashwat Babu from IIIT Dharwad.
Very good afternoon to all of you, sir. So I take this opportunity to first thank NQM, not only triggering this the quantum revolution in our country, and also taking together in this journey the AP State Council for Higher Education. And I would like to thank Chairman sir for the opportunity to have a parallel faculty development program along with the AICTE to start from the state level. And it's a very encourageable and uh, appreciable the initiative, because maybe a national level AICTE, probably the timings and probably the concentration may not be possible at the state level. So the AP state has took that into a second level, and they are concentrating the faculty from their own state. So that is a very, very nice thing to have. Yeah, in that process, NQM is assisting the AP State Council. So kudos to them for that. And along this way, not only just engaging in AP like AICTE, FTP, Pillai sir is also involved here. So thank you for Pillai sir also for that. So doing not dual job, I think multiple jobs. I think apart from this FTP, he is also involved in other things. So thank you for that, sir. and giving us the opportunity. Like Mustafa covered most of the things. It's a privilege for us to share the thoughts and ideas which we gathered during our PhD and so on. Uh, so it's not like we are going to teach, it's we are going to learn together with the faculties from Andhra Pradesh. So we had a very interesting and fruitful first module where there were very, very interesting questions were posed, which even triggered a lot of interesting understanding and in ourselves. So we are updating, like Mr. Fisher was mentioning. So we are looking forward to have one more interaction with you all with this module, and it is nicely planned, a 60-hour session, 60-hour a program covering most of the fundamentals. So please pay full-fledged attention from your end, and if not possible by any means, not due to some other engagements, we understand. So try to check the YouTube recordings or any other means of recording, and keep yourself uh, prompt and up to date, so that you would able to understand the later sessions, right? So please don't take it any, like there are sometimes you see this schedule, there are topics which were taken from here and there. It may not be like that. So those were really required for your quantum computing, your programming, and your logic. So everything is important. Ensure that you get to know those things, and you're always welcome to reach to any of the resource person through the organizers. So we would be very happy to get in touch, and we can do together learning. So that is from my end. So once again, I would like to express my gratitude to the AP State Council and also the Pillai sir from MNIT. Thank you, sir. Over to you.
Thank you. Thank you very much. Anil sir, will you be able to speak? I think. Okay. Yeah. Please go ahead.
Sir, good evening. I thank Honorable Chairman Sir, Professor M. Mahmood Sir, and Dr. Iman Sir, Aswad Sir, Mustafa Rahman Sir, and Jay Kumar Sir. Namaste. And I think Vikas Kumar is also there. Welcome, sir. Sir, this is a really wonderful program in collaboration with so many organizations like MNIT, IIT, IBM, TCS. So many stakeholders are involved, including the faculty. This is just because of the drive and vision by our Honorable Chairman Sir. And today, even in SV University, the Vice Chancellor actually, he also impressed upon the activities that are taken up from APSCHE side. So actually, he wanted to also connect, but due to his other engagements, he could not able to connect this. But he is also very much impressed with these all the activities. Not only the faculty development programs, the faculty development program is a massive program, and apart from this, we are also in collaboration with other stakeholders. I'm going to train the students, almost 50,000 students. Maybe it is a world record. And not only the student strength, that of the time, within 6 months, they wanted to train 50,000 students. This, if we can make 50,000 students trained, it will certainly will make a world record. It is all because of all stakeholders like you and our chairman's dream. With these few words, I thank you all, because I am also engaging in another workshop. Thank you all. Thank you. Thank you.
Thank you. Thank you very much, sir. Yeah, over to Dr. Jay Kumar, who is there with us, and who is the main resource person. Most of the sessions will be handled by Dr. Jay Kumar. One thing this time, what we tried, and sir has been very kind, he has sent us some assignments. So you please do that. You have about a few more days before he actually starts the simulations part. So please finish the assignment. Maybe I'll request Jay Kumar sir also, before he starts the lecture today, he'll share a few these things, show how the things can be done, because some of them are not aware of Jupyter Notebook and other things. So not the solutions, but he'll do that. Then while he is teaching, he will give you an assignment after the course is over. Somewhere around 15th, he will complete his lectures. So he'll give you an assignment. You'll have 15 days time, and he'll come back on November 29th for a hands-on discussion. So he will share the solutions on that day, and those who have some doubts. So it will be more of a, it will not be a teaching session, but it will be a doubts clearing session. So we have kept 2 hours specifically for that. So you will have to do the assignments and then come back. We will also know how much you have learned. That will be a test for us as teachers. We are teaching, he's prepared the assignments. 5 assignments have been given. So you please go through those assignments, try to solve them. If you are attending QT-03 directly, then go back, refer to his 3 videos, day 9, day 12, and day 14, I think, some order. So you look at those videos which are talking about these simulations. Already he has taught. So please go there, refer, start that practice. You will be able to solve the assignment. Not a very difficult assignments per se. So that's what I would like. So I over to Dr. Jaykumar sir. Before he starts his lectures at 3:30, he'll just share few. I mean 3:35 now. So I'll let him share few thoughts, and then I'll request Dr. Vikas to share word of thanks, and we'll start the lecture. Yeah, over to Jaykumar. Few words.
Good afternoon, sir. Am I audible?
Yes, yes.
No, you are not
audible. No, not audible. No.
Still no. Not audible.
Hello.
Yes, you are now audible. Yeah.
Okay. So good afternoon to one and all present here. It's my privilege to be here. I thank NQM Andhra State Council and Emmanuel sir. Before 5 years, I am one of the participants of Emmanuel sir FDP. They conducted in MNIT Jaipur. So that is how I developed myself into quantum. I am also a beginner, just like the participants. So I wish you each and everyone all the very best. We'll learn together. Thank you.
Thank you. Thank you. Yeah, I remember the time where 2021 we had the training program. At that time, only 100 people participated. Dr. Jaykumar was one of the participants. But after that, we have seen him tremendously developing himself, reaching the level of IBM educator, qualified by IBM to teach quantum courses. And he has taught in most IITs, NITs, and IIITs across the country. So that's where now today, so you may be in next 3-4 years, most of the participants may reach that stage, I hope. And I wish that some of us will become like him and take it so seriously and passionately that he does, right? And one thing as a caution before we conclude with Dr. Vikas Kumar sharing the vote of thanks, please remember it's a virtual program, nobody is watching you. You can just get the attendance, you can get the quiz, you can write the answers from Google or somewhere, but it is up to you. We are giving the content, the teachers are spending a lot of time improving the lectures and giving the content to you at nothing. 500 rupees is nothing these days for 40 lectures. You make use of it, your choice. You want to bluff us or bluff the system, no problem. We are not worried. We are creating a content forever. It's going to be there on YouTube forever. We are fulfilled. Our job is done. We will put the 12 lectures completely online where all the students can learn anytime. But as participants, as faculty members, mostly AP State Council is heavily investing in your efforts. They have given you permission. Classes are adjusted. Timing is set like that. Faculty are coming from IBM. Anupama Ray, very senior scientist. She teaches in IIT Jodhpur for a course. She's teaching you, and it's a rare opportunity if you understand the seriousness. So please take this course seriously, take the content seriously, and if at the end of this month, if you're not good in Qiskit programming or Penguin programming, then you are doing a great loss to yourself, I would say. So hopefully there are so many opportunities which will open up because the quantum boom is going to come in 2-3 years. It will be so much, it will be there. So at that time you will think, Array, I did the course, but I was not serious. So you have missed the bus. So please take this seriously. Over to Dr. Vikas to conclude.
Thank you, sir. So, good afternoon, one and all present here. So, on behalf of the ENICT MNIT Jaipur, I take this opportunity to extend my heartfelt thanks to all who made this inaugural session a success. Okay, our sincere gratitude to Professor K.M. Murthy, sir, Honorable Chairman APSCHE, for gracing the occasion and for his inspiring address that highlight the importance of quantum technology in shaping the future education and research. We extend our special thanks to our director, MNIT Jaipur, for his vision and constant encouragement, which continue to guide and strengthen the initiative of the ENICT Academy Jaipur. We are deeply thankful to Professor Vinit Saula, sir, who is the PI of this ENICT MNIT Jaipur, for his continuous guidance and leadership, and obviously to the ES Pilli sir for his tireless efforts and excellent coordination in organizing this FDP at such a scale and in collaboration with APSCHE. Our appreciation also goes to all the eminent speakers, participants, and organizing teams for their contribution and support. And I thank you all for joining us today. We look forward to an engaging and enriching FDP ahead. So thank you all, and I welcome you all to this FDP. Thank you so much. Thank you, sir, for joining us.
Thank you.
Thank you, Madhumurthy sir. Thank you for joining. Thank you, all the speakers. Yeah, we will start the first lecture now by Dr. Jaykumar. Most of you know Dr. Jaykumar. He's founder of and CEO of Anutantra, which is a startup focusing on quantum. He is a qualified IBM educator. He will share during his lecture some of the badges that he has earned. So many badges he has earned from IBM and other courses as well from Amazon also and AWS and other things. So he is very much interested and passionate about learning and also teaching. So, one more thing he was mentioning that he's also a learner. So please, nobody has gone very much and mastered quantum. All are in the initial days. Some have gone a little bit ahead, but so we are almost there. So it will be a few months. You can also become as knowledgeable as all of us. So I think so that please remember that. So with that, and then he's been traveling across the country and also in other countries as well to deliver lectures on Qiskit and other things. And AWS also, he's a qualified subject matter expert, and hence that's and then there's a team of people also, as we see, who are working very closely with Dr. Jaykumar. So at this time, I just would like to give you a brief introduction to the syllabus. QT-03, most of the part is there. QT-04, the software simulation part is there. And we are also looking at 3 different companies coming and speaking of how they set up a quantum computer or how to set up a quantum lab. Some of these concerns will be discussed on 26, 27, 28, 3 days. We'll see. And if some of them are not able to come, then it will be Dr. Jaykumar who will be clarifying doubts and giving more assignments, and we will discuss. It will be more of a hands-on lab session, which will be there because it's a lab. That's what this course is. So initial few days will be on programming, as Professor Madhumurthy sir already shared. And later we have the mathematics part, that is numerical integration and differential equations. Then we have the simulation protocol simulators that we will discuss. We'll have an introduction to applications of quantum mechanics. So some of the coding part of quantum mechanics we'll discuss. Then cloud-based quantum processors, how to access IBM quantum processor to run algorithms will be taught. And then we'll go to quantum machine learning, as I was already shared. Then integrating high performance computing with so a hybrid quantum plus GPU combination we'll try to have. And then we'll have quantum errors and mitigation using Qiskit. Ritajit Majumdar, IBM, he is one of the developers of Qiskit. So he will be sharing the thoughts on errors, and it's very important concept of errors. If you reduce the errors and if you make it 0, a quantum processing quantum computer is ready. So as of now, that's the challenge as we look at how to handle, how to reduce the errors is what is another aspect. Another numerical methods on probability and statistics. Then applications to electromagnetic theory. some of the coding assignments we will discuss, and then we'll conclude with the hands-on valedictory session, hands-on session on the assignments that are given. So the solutions will be discussed on that day, and some doubts, if any, will be clarified. So over to Dr. Jaykumar for the first session. We'll all take leave. Madhumurthy sir, thank you so much for joining for the inaugural session. Thank you, Dr. Mustafizur, Dr. Ashwath, Anil sir, and Vikas. Over to Dr. Jaykumar.
Thank you, sir. Now, sir. Hello.
Yes, yes. Yeah, Dr. Jaykumar.
Yes, sir. Okay.
A little bit the voice is low. You can slightly increase volume.
Now,
Yeah,
I'm audible. Yeah.
Yes.
So, good afternoon to one and all present here. I welcome you all for this QT-03 and QT-04 lecture series. And today, the given topic is about basics of programming, data structure, classes, and object-oriented programming. If you look at the title, it combines 4 individual courses. So in computer science and IT, basics of programming is a separate course, data structure is one another big giant course, and object-oriented programming. So we try to give a very brief overview about all these topics. We are not going to discuss in depth. So it will be like a refresher for you. So if you are from computer science or IT or from other department, so it will have a brief overview. So please cope up with if you're already from CS and IT. Okay. So I want to start with this wonderful quote given by Steve Jobs. The only way to do great work is to love what you do. Okay. So this is my motto, my life of all this stuff. So whatever I do, I should like it. When I will like it, if I really love it, to do that work. Okay. So all of us gathered together here to learn quantum computing. So to learn quantum computing, we need to start from classical computing, how the things are get done through classical computing. So this is one more quote given by Harold Adson. Programs must be written for the people to read and only instantly for machines to execute. So first of all, if you are writing any program, it should be understandable by the people, the co-peer developer for you. So might be a teammate, might be your team leader. Okay. So might be your students or supervisor. The program must be written for the people. Okay. So if you are able to write properly, there is less difficulty to read by other people. Okay. So accidentally it will be executed by the machines. So you need to take care about how we are writing the program. So the first step is solve the problem. Okay. To solve that problem, we need to write that code. So most of the time we need to spend understanding about that problem. Okay. So most of the 2 voices are coming. Maybe I will remove. Is it okay now? Is it okay? Without mic, I will speak.
Yes, sir. This is better.
Okay. Fine. So most of the time, we need to analyze that problem. We need to understand that problem. Then we need to write a code for that. Okay. So people, if they are talking about the coding, they only see about the coding part. The important matter is how to analyze a problem. How we need to invest so much of time for analyzing problem rather than writing code for it. So writing the code will take less amount of time. Okay. So as of today, quantum system do not operate in isolation. So whatever we are looking in QT-01 and QT-02, quantum system will not in isolation. It will be like hybrid, just like Emmanuel Pillais are told. So it will help the classical system, whatever we are already having, it will help. Okay, so some part we need to run in quantum, some part we need to run in classical. So it will complement each other. So this is the future. So whatever you know already classical computing, if you learn quantum computing, it will belongs to hybrid computation. Okay, so why we need to go for hybrid computation? Because we need to solve most difficult jobs. So that is the idea. So when you write a program, this is like just receiving the user input and processing it, then display the result. Okay, so managing job payloads and facilitating various other computational tasks. Okay, so the coding part will take very less amount of time, but the receiving part from the user, the input. Okay, if you are getting input from the user, this is direct data. If you are gathering data through sensors, it will take some time. Okay, so each and everything will impact your computation. If there is a delay in your input, the delay happen to your computation also, right? So everything is interlinked, and we need to understand how the ecosystem works when doing a computation. Okay, suppose if you are integrating classical plus quantum, if there is a delay in classical part happening, it will impact the quantum processing also. So we need to understand this sequence. Okay, so once you have the knowledge about quantum algorithm, it will give the leveraging the power of both classical and quantum system. So in some cases, you can write quantum algorithm without using quantum computer also. Quantum inspired classical algorithm, that is also possible. So future is about hybrid computation, not quantum only. Okay. So currently, if you want to execute any quantum computational jobs, so this is possible by made by specialized library, which will act like an interface between user and quantum hardware. So this is our aim. After learning this course, you need to know how to write a quantum algorithm or program, and you need to submit the job to real quantum hardware. So this is what they are talking about. So once they installed actual quantum computer in Amaravati, then you need to know how to put job for that. Okay. So all your quantum computational job will go and step in queue and executed one by one. Okay. So to do this, we have ample amount of library. Okay. So majorly I will focus on IBM Qiskit. Apart from IBM Qiskit, Google is there. Google developed a separate tool called Circ, and Microsoft developed a separate language called Q-Sharp. Okay, so similarly, you can look for Penny Lane. We're going to discuss Penny Lane in upcoming lecture, and Amazon also having a separate tool called Bracket. So each and every MNC, they have individual tool for quantum, and all these tools are interoperable. It means if you know IBM Qiskit, you can convert that coding to Google, you can convert that coding into Microsoft. So interoperability is not a big problem in quantum. So you need to understand this. So if you know one tool, that is good enough. If you know 2 or 3, you are able to compare, then you can pick your right tool. Okay, so this library allow you to construct, simulate, and execute your quantum algorithm on real quantum processor. Otherwise, you can use simulator. So 95% of the time in this course, you will use simulator. Okay, for learning, for the initial step, executing in simulator is more than enough. So once you got confidence, if your programs are worth enough, then you can go for real quantum systems. Okay, so this is very imperative to develop proficiency in these tools and library. If you are a learner, okay, then you need to understand how to formulate and execute quantum program. So formulating a quantum program will take some time, okay, which is tailored to the specific computational problems. So if you are writing a classical algorithm, so it will be helpful for most variety of problem, but quantum program only for specific problem. Okay, so quantum computer need to be utilized only you have computational difficulty. So we need to keep this in our mind. Okay, for the beginner, it is okay, we can write small problems, okay, example problems. But if you go for real system, you need to have that much of reason why we go for real quantum hardware. Okay, so that is why it is too costly. So to execute any quantum program in IBM system, real IBM system, they are charging 8,000 rupees per minute. Then you can understand only for solving important problem, you will go for quantum computer. So imagine like this. Okay, so a huge amount of money always involved, because so much of resources they are providing, and you will get equivalent output, equivalent benefit out of it. So by mastering these tools, we will take a crucial step towards the leveraging power of quantum computer. It is spanning about the different application. So it will lead to scientific discovery, optimization problem, cryptography, and you can do material synthesis. Okay, so all these kind of different scientific computing you can do with the help of quantum computing, right? So this will designed according to the tailor-made, according to the specific challenges and computational requirement. Okay, so each and every topic are very, very different and unique, and accordingly we need to write quantum programs. So for that, you need to learn a few languages. So in this lecture series, we try to cover Python, Julia. Okay. So in future, Rust programming language will take place more and more. Okay. So try to take note of Python, Julia, and Rust. And if you are from different disciplines like physics, mathematics, irrespective of your domain, quantum will help you and quantum will support you. So whatever the computational intensive problem you have in your domain, you can check whether quantum computing will solve your problem. Okay, it is worth to invest time in quantum. So we try to start from basic programming. Okay, C and C++ have been long favored about their ability to provide direct control over the system resources. Suppose if you want to access the real hardware, these two languages are very best. Okay, even though IBM using Python, in future you can integrate C programming in Qiskit also. So they are providing native support for C programming. So people who know C programming without learning Python directly able to write programming in quantum computer. So this is one good news, and this will allow excellent performance optimization in large scale simulation and real-time system. Even now, if you're taking any embedded system, C will dominate. Okay, device drivers, operating system. Okay, so each and every language have unique strength, and C is almost still holding the majority of the technological prowess. Okay, so these languages will require deeper understanding of memory management. If you are using C++, it is the user responsibility to understand how to manage memory, how to allocate and how to deallocate. Sometimes it could be more complex. If you are using pointers, we need to be very, very careful while dealing with C and C++. Okay, so Julia is relatively new programming languages designed for high performance numerical and scientific computing. So you can take note about Julia. Today you go and check about Julia. Julia is very, very relative new programming languages, which is having the similar syntax of Python, very easy to write program when compared to C and C++, but it will execute in very faster way. So comparatively, it will execute as good enough to C and C++. So most of the gaming, still they are writing coding in C and C++. So whenever there is a performance demand is there, they will go for C++. Also, Julia is also suitable equivalent to C and C++. So in future, Julia have potential to replace C and C++. Okay. So very new language have multiple options, multiple complexities. Okay, so take an example of solving a differential equations. Okay, processing a large data sets, Julia will help. Okay, Why Julia is taking the highlight? Because it will execute almost the equal speed of C. And it is very simplest level to write a program for all this stuff. Okay. This next worth noting language is called Rust. We already talked about Rust. Okay, Rust is become increasingly popular due to its ability to ensure memory safety and also support for concurrent programming. So if you take C and C++, you can manage memory in very good way, but it is the responsibility of programmer, developer. Sometimes if you forget to deallocate the memory, so much of inconvenience will take place. But in case of Rust, it have the inbuilt ability to control the memory safety. Suppose if you are allocating memory for a particular task, after the end of the task, it will deallocate automatically. And also it will support for concurrent programming. In C and C++, you need to write specifically, but Rust have inbuilt ability. So that is the slight difference between all these languages. Okay, so these three languages are very, very suitable for performance intensive application that requires high reliability. So nowhere I am talking about Python, because Python is much more slower when compared to C, C++ and Julia and Rust. It is 20 times slower than C and C++. So if you feel Python is very easy for you, but you need to pay the overload for that, okay, the overprice for using Python. So something is easy for you, back and something is holding back. Okay, the difficulty or lack of speed, okay, where Python has. So all this, despite of all these advantages, most of the developer, current generation developer, they have fond with Python. Okay, so most of the scientific community adapted Python because of this simplicity. Okay, because it is very simple and the Python code is very, very readable and it is incredibly accessible. Okay, so people from other background, if they want to learn C and Python is obviously easy for them. People from physics, chemistry, maths, even economics, Python will be easy. And it have bigger community. Comparatively, C and C++ have very big community, but learning Python is very easy, comparatively easy. Okay, is somebody coming from non-programming background, okay, it is easy for them. And Python have very good ecosystem of library. Okay, because if you are from mathematics, you can use NumPy. If you are from physics and chemistry, you can use SciPy. Okay, yeah, if you want to visualize data, you can use Matplotlib. Learning programming languages always depends upon how much you are familiar with programming language already and how much of effort you are putting. Okay, so maximum 2 to 3 months. For my understanding, 2 to 3 months is enough to learn any computer programming. To master it will take some time. Okay, entirely depends upon how much frequently we are using, how much frequently we are utilizing. Okay, very tough question actually. Okay, Python offers comprehensive toolkit for tackling wide range of scientific problem. So that is why IBM adopted Python for this quantum programming, because the language should be easy and any person from any background easily able to learn that language. Because of that reason, they selected Python for their interface. Okay. So it balances easy of use with powerful capability, making ideal for rapid prototyping, okay, data analysis, even complex simulation without steep learning curve of other languages. So here it is the important point. If you want to develop software in very faster way, Python will help you. Okay, developing in C, C++ will take much more time when compared to Python. Okay, and also the learning curve is very, very easy in Python. So within 1 month, you are able to learn most of the stuff from Python. Okay, So mastering a language is debatable, but learning is uttermost easy in case of Python. Okay, so we already discussed. I'll skip this slide. So why I told all these points, because you need to know the reason why we are focusing in Python in Qiskit rather than other languages, because all of this reason. It should be simple, it should be adaptable from different domain people. That is the main use case of Python in the terms of quantum. Okay, so not only IBM, even if you take Google, all these languages, all these quantum programming written in Python. So if you know Python, you can work in Qiskit as well as you can work in Google Circ. Okay, Python make your life very easy in case of quantum. So if you want to learn programming, you need to know the basic principles of programming, key principles. Your program should be have the clarity. It should be very simple, and it should be have modularity. Modularity means you're able to divide your program into separate packages, okay, separate modules. And you should not repeat yourself. Once you created code, you can use the code as much as possible, like code reuse. Okay, and also it should be efficient. It should be efficient. It should be maintainable. Okay, so if you are developing code for yourself, for a single person, it is not a big problem. But if 100 people, 1,000 people, million people are developing for the same project, very big project, then maintainability will become an issue. Okay, the programming language should contains all this stuff, able to handle all this stuff. And one more important property of a programming languages is about error handling. Okay, so most of the time, if you are a new developer or new programmer, errors will come frequently. You need to handle that error. Okay, whenever if you are looking at the error, your composer or interpreter need to tell what type of that error. More it is giving information about that error, easy to fix that error. Okay, so this is very important thing. When you are designing any programming languages, it should be easily able to handle error, right? Then it is the question about scalability. If you are writing a program, whether that program is able to scale for 100 people, 1,000 people, or multiple application, are able to scale it up and scale it down. So it depends upon the demand. You're able to increase the scalability, and you need to reduce the scalability. The next important property about programming is about testability. Anybody can be able to write a program, okay, but anybody cannot able to identify error, able to test that program efficiently. Okay, sometimes if you are writing a code and if you are executing, you may miss some errors. Okay, so syntax error you cannot bypass, system will tell you. But logical error, sometimes you will forget to notice. So during that time, software testers will identify and they will report to you. Okay, so the next important topic is abstraction. Abstraction is about hiding the hiding about the unnecessary details, only showcasing important details to the user. Okay, according to the scenario, we need to do abstraction. If we take our laptop or computer, they abstracted most of the hardware. You no need to know how processor works or what are the instructions given for the processor. If you simply open an application, you can access that hardware. So your mobile phone, your laptop, your computer, excellent example for an abstraction. Then encapsulation, reusability, all these topics we're going to cover, right? So these principles will serve as guidelines to create a well-structured, efficient, maintainable code. Suppose if you are a programmer, if you are a developer.
Namaskar, sir.
So, yes, sir. Okay, fine. So this is very important property. So anybody can write program, but all the program are not supposed to write in well structured. So if you're writing program, you always remember your program should be well structured. Okay, indentation, all this stuff, and it should be efficient. So writing a program to solve our problem, right? The efficient solution will give a much more advantage when compared to multiple solution. Okay, it should be maintainable. So maintainability is a very big task. Initial days, we don't know how to maintain your code, but if your code repository evolves, it will be a tedious job. Okay, for that we need to use GitHub to maintain the code repository. Okay, so mastering all this principle is very crucial for any programmer. Okay, so this will help them to provide a foundation for building a complex system, writing clean, understandable, scalable code. Okay, so most of the time lecturers, they go straight away to the problem. They will discuss as their students to write code. So in future, if you're teaching any programming, you always focus on all these topics, try to inculcate in your lecture. So how to ask them to maintain a well structured code. Okay. So this will yield to high quality code. So if you follow all these principles, so what we'll get very, very high quality code. Okay. So if student go for an interview, okay, so by looking at the way they are writing the code, sometimes they will hire. Okay, it is not always about writing a code and identifying the solution, how they are presenting, how they are maintaining. Okay, with that appearance, they are able to get some job. So computers only know how to do and what we need to tell them to do. So computer is a device, it will know how to do, but we need to instruct. So that is the main aim for our program. Okay, when you're writing any program are equivalent for algorithms. Okay, so computer work algorithm. Okay, so programs communicate with the computer and tell it what to do. Okay, so go to the first line and second line, you are able to know, right? So the conversation happens between a developer or a programmer to the computer via the program. So it is like a language known to both parties, right? So before writing program, we need to focus on algorithms. So algorithms can be expressed as a program in many different programming languages, right? Different languages use different syntax, wordings, commands, but they all share the same set of algorithmic concepts. So irrespective of your programming tool, irrespective of your problem, okay, certain algorithmic concepts are very much similar. If you're able to master that algorithmic concept, learning any programming language will be very, very easy. So someone asked how much time to take learning Julia and Rust. Okay, if you already know C and C++, if you have good knowledge about algorithmic concept, okay, you can use cheat sheet to compare both languages. What are the commands differ from C and Julia? If you're able to get that point, learning a language will happen within 1 month also. So this is how a developer working in a company learning new languages without much effort. So if you are from IT and computer science, forgive me, this is for non-IT people. So we'll start from the basics. So what is a computer? In our history, we are using multiple types of computers, multiple kind of devices. We use abacus, then mechanical machine. We the analog computer, then ended with digital computer. Okay, so this is how the evolution happens. So computer is a machine. Okay, machine for computation. Okay, essentially it is no big difference from abacus. So if you take abacus and digital computer, you can say so much of difference by appearance, but logically there is no big difference. Okay, So whatever you are able to do in abacus, you are able to do in computer. So basically, computer is advanced version of abacus. Okay, computation point, both are same. So computer is a device. So computing is the process which is done in the computer. Okay, so computing is a process. To do that process, we need to have some data. So input data, and we need some operations. Okay, so if you are doing some operation, we'll get output as the answer. Okay, so this model is proposed by Alan Turing. So today, after this class, please go and search about Alan Turing, one of the mathematician who contributed a lot to computer science. So because of Alan Turing, we evolved to computers. We can say proudly in that way, right? So he proposed the Turing model. From the Turing model, we evolved to John von Neumann architecture. So he's the first scientist. He proposed computer architecture, how to store your data, how to process your data, how to give instruction. Everything is proposed by John von Neumann, computer scientist. So each and everything evolved from mathematics. Okay, so computer science evolved from mathematics. So I'll briefly tell, most of us know. So computer have major components: CPU, central processing unit, memory, hard disk. Nowadays we have SSD. Then we have keyboard to give some input, and we have graphic cards, monitor and screen, and we have additional peripheral devices: music card, microphone, speaker, and finally we have mouse. So all these devices, peripherals, will make a wholesome computer. Okay, so computer contains CPU. So within this CPU, we have data bus, we have instruction bus, we have address bus. All our data are stored in memory. If you are giving any input data, it will be stored in memory. Then it will give to CPU. CPU will process your data. All this data will transfer through data bus. To access your memory, you need to have address bus. Okay, so each and every operation will be given through instruction bus. Okay, so if we have computed data, then you need to store that data in hard disk. So this is how basically it works. And why we need to know this architecture? Because it is relevant to quantum computer. Okay, so if you look at quantum computer always integrated with classical computer. So I will take pointer over here. So this is your classical computer. From classical computer, if you are writing any code, okay, any programming code in quantum sense, okay, this will go in this way. Okay, it will reach your controller, quantum controller. So quantum controller will convert into equivalent quantum signals. So that is transmitted over here. Okay, here you have quantum processor. So your quantum processor will execute all the instructions given by the signal. It will resend the data through this wire. Okay, again the signals will come. So all these quantum signals are converted into data, equivalent data, classical data. It will reach your computer. Okay, so if you don't know the classical architecture, you cannot understand how quantum computer works. So that is why we started with basics of classical. Okay, so this is how it look like, the framework look like. So here you can notice here you can notice quantum signal amplifier. So what are the signals you got from classical computer? It is got amplified, and these are converted into microwave pulses. So your input is converted into microwave pulses lines over here. It will come down, and the mixing chamber will generate the equivalent cryogenic temperature, and all your signals will go through these wires. Okay, here your quantum processor will be there, and your computation or get done in quantum processor, and the results are sent back to wires again. So all these signals will come back to here. Here the microwave pulses again converted into quantum signals or qubit signals, again sent back to your classical computer. So this is how it is get done in the computer architecture. To understand this, we need to start from what is the meaning of programming. So most of us, we know the father of modern day computer is Charles Babbage. Okay, he created a mechanical computer. So this is the first mechanical computer, and Ada Lovelace is first computer programmer. She is very good programmer. First programmer is Ada Lovelace. And this is how it works. So whatever you gave input data, all your data will reach your memory first. From memory, it is transported to CPU. Your processor is there. Okay. So data from memory. So your data will go from here. Okay. It will get processed. Then all your computed data will again go back to your memory. Okay, so memory will act like an interface. Whatever you gave through keyboard or mouse, all your data will come through memory. Okay, will get stored in memory. From memory, it will go back to CPU and back forth. Okay, to know all this stuff, you need to know memory location. So that is why we have memory bus. So downside, you can see this arrow mark. This is called memory bus. So you need to know where to store your data. So all these instructions on data fetch from memory to CPU for processing, and the results are returned back to memory. So this is how it is working. Okay. So what is the problem over here? The computer only know the binary languages, machine level language. Okay. Humans, we know only high level languages. So initial days, the programmer able to know the combinations of zeros and ones because the program is pretty easy. But nowadays the operations are very complex. We cannot directly give zeros and ones. It is almost impossible. So that is why we need to learn high level programming languages. Okay, so natural language is the media that we communicate with each other, right? How we are communicating right now through English. In the same way, we need to create a computer language. Okay, so computer language is the media how to communicate with a computer. Okay, so that is why we created so many languages, C, C++, Python, to communicate with computer, and we should use that language that with the computer to get understand, right? So for that, we need to have a interpreter or a translator, or you can say compiler technically. So this is how we are doing. Whatever the language we know, C, C++, it is termed as high-level languages. Okay, it is easy for the programmer to understand. It contains most of the words naturally, and all these things are translated into programming. Okay, so your translator, your interpreter, or your compiler will convert into binary that is sent to your machine. So that is called machine code. So all your binary data, binary form of data is called machine code. Okay, so once your computer understand all this stuff in binary form, it will compute and it will send back to the user. So this is how your data look like inside a electronic component or computer. Okay, so once you have binary code, machine code, so left side you can see the machine code, then you need to convert into assembly level language. So whatever, if you are looking at the right side, is called assembly level language. Okay, called op code or operation code. So which is readable. Okay, when compared to binary, we can understand, move, add. Okay, D1, D2, which is readable, will have some sense. So you can convert binary to assembly, assembly to binary, both are possible. So this will act like low level language. Okay, so assembly level language is called low level language. So this is an example for adding two numbers. So what this machine code assembly level language will do, it will add two numbers and it will store a result in separate variable. So you can understand this. A equal to 3 plus 5 means it involves addition operation, it involves two variables, and it involves storage computation in another variable. So have a glance. So move D10011 means 0011 is value of 3. This 3 is moved to D1. So this is a register. Consider it is a device. Okay. So your value 3 is stored in D1. So next instruction, move D to 0101, which is equivalent to 5. The value 5 is stored in D2. So these two inputs are moved from your keyboard to the memory. From memory, it will move to your processor. So this is what happening within first two instructions. The next instruction is computation. So line number 3 is about add D1 and D2. So what it will do? It will do addition between two variables or registers. So 3 plus 5 will happen in this way. So look at line number 4, move D1 A1. So what it means, if you are adding D1 and D2, the result is stored in D1. Okay, that D1 result is moved to A1. Now A1 is equal to A. So this is how you need to interpret. So whatever you are writing computer programming, all your computer programming lines are converted into assembly, and assembly language also converted into machine code. So who will take care of converting all these steps? Here translator. So in computer, translator is nothing but compiler. It could be compiler or interpreter. So this is what you are writing in C or C++ or Python. So all these code are converted into machine code with the help of compiler. So here I abstracted assembly level code. So this is an example for abstraction, right? So high level language converted into assembly, converted into machine code. So normally we'll write a text file in a specific format like a grammar, right? So these instructions that we basically understand, the translator will convert the text instruction into machine code. Then machine then runs on this binary code one by one. Okay, so different translators lead to different programming languages. So like if you want to converse with Japanese people, we need to have a Japanese translator. If you want to converse with Chinese people, we need to have a Mandarin translator. So depends upon the programming languages, we need to have different translators. Okay, so each and every programming language have different grammars, like different languages. So this is a lifetime of a computer program. When you write any computer program, okay, that computer program is converted into machine executable code, binary level. Okay, so that is stored in your hard disk. Okay, so after some point of time, you are able to load to your operating system and able to execute your code. So this is how it will happen. So whenever if you want to store any program, you need to store in your hard disk or SSD. So we will discuss how C became popular in the recent decades. It started from 1960, starting from language B, evolved from language B to C. It is improved version of B. Then C evolved in different languages. Okay, so many languages inspired and derived from C. Take an example of Python, Java, C++, C#. Most of the language evolved from C. So if you know C, learning all these languages, mastering all these languages, pretty easy and pretty good. So Python is simple and highly useful, okay, because it is very easy to read and write. And it contains huge number of libraries we already discussed. Okay, the main weakness is efficiency. it can be slower than other programming languages. So before, if you want to learn any programming languages, if you want to learn any programming languages, you need to know its strength and weakness. At which point we need to pick which languages. So for most of the time, okay, we need to keep the track of your data. Okay, so that is why we go for computer. So we need to process some data. That is why we use computer, right? So we need to track the flow of data from one component to another component. Okay, so each time some changes will happen over your data. Okay, to understand your data, you need to know its difference property. Okay, so depends upon the property, you can categorize your data into different types. So we'll start from basics, numbers, text, and truth values. Okay, so these are the core types of data. And you have a very wide range of data structure. So you have simple data structure like array structure, and you have compound data structure. You have linear, non-linear. In case of linear, you have stack, you have queue, you have linked list. In non-linear, you have tree and graph. So this will give a broad idea about the data structure. Okay, how we going to organize our data inside our computer and process in the computer. And there are so many data types in statistics. Based upon the statistics, you can categorize your data types. Okay, so you can divide data type into two categories, categorical and numerical. If your data belongs to ordinal and nominal, it belongs to categorical. If your data having some intervals, if your data having some ratio between them, then you can classify as numerical. So based upon so many contexts, you can have different types of data types. Okay, so based upon the programming, you can categorize data types into number of types. So integer, float, double, character, string, boolean. If you want to store date and time, okay. So if you have some array, if you have some kind of matrix, then you can go for 2D array. Okay, so based upon your purpose, you can pick your data type through your programming languages. So this is very important. So before learning any programming languages, try to explore how many data types that language will support. Sometimes that language will not support your data type, then it will be difficult for crucial applications. So we'll discuss the basic data types. So in Python, in case of Python, we have numbers. Okay, in case of numbers, we can categorize into integer, float, complex. Okay, then we can pick Boolean. Suppose if your data type contains only two values, true or false, yes or no, 0 or 1, then you can go for Boolean. So in most of the cases, if you're able to reduce your data like a Boolean, it will occupy very less space. So this is very good point. You can take note about Boolean. Okay, then you have set of data, okay, which belongs to a particular group. Just like mathematics, you can use set, and you can use dictionary data type in Python. Okay, it will come with pair. So key is there, and key is also associated with value. Okay, then if you come for sequence, you can store like text, string. Okay, then you can go for list, then you can go for tuple. So depends upon how you want to store your data, how you want to process your data, you need to pick your data type. For an example, suppose if you want to store integer, okay, 0, 14, 7 or whole numbers. In case of fractional, you can select floating point. Suppose if you have decimal point, then you have different types of data structure. Okay, so picking a floating point to store an integer, it is a wrong decision. So what it will cost? It will cost the extra memory. So whenever if you are writing any programming languages, you need to always have a caution about whether that data type is really needed for your data, whether it will cost extra memory space. So this is valid point. Okay, so all these operations will lead to computation. Generally, numerical computation, plus minus, star for multiplication, slash for division, double star or asterisk for power computation. Okay, then we'll use parentheses to specify order to evaluate. Okay, so we will discuss later in programming. We'll discuss all this stuff, right? So take an example, 4 double star 2, it means 4 to the power 2. So here you can refer over here, right? So if you want to do 5 minus 2, then put the parenthesis, then followed by slash, then followed by 3, then this equivalent to an expression. So it is a arithmetic expression. Okay, so all these arithmetic operations are called as an expression. So each and every instruction you can consider like expression, computational expression. So what happens if you give this computational expression? It will evaluate data one by one. So first it will load 5, then it will load 2, then it will do operation of minus in between them. Then to the whole result, it will do division by 3. So each and every time you'll have sequential operation in classical computing. So most of the slides are repeating. Yes. So some cases operation will a little tricky. So take an example of floor division. When you give double slash, am I audible? I hope so. Yes, I am audible. So if it is not audible, please rejoin. Please rejoin. Yes, yes. Thank you. Thank you. Okay. Suppose if you want to round off, you can use floor. Sometimes you can do advanced type of operation by picking right operator. Take an example of modulo. So this will not give the answer like division, but it will give the remainder, right? So some operator will give entirely different results. Suppose if you want to represent text values, so text values are called strings in Python. Okay, so text is recognizable in Python by putting single quotes or double quotes. So if you give single quotes, it is recognized as text. If you are giving double quotes, also it is recognized as text. So multiple ways to represent your input. Okay, and you can concatenate. I will share this slide. I'll share this slide, very easy. If you don't know about anything about computer science and programming, easy to follow. So don't worry about these slides. Okay, then you can add two strings like using an addition. So like 5 plus 3, we got as result at 8. Here we are able to add two words and it is called concatenation. The same operator, okay, executed in different data type will lead different results. So we cannot having the same sense like in normal way. Addition operator only for numerical, not for adding any strings. But computer cannot understand how to merge two words. So we are reusing the same symbol in different context. I will explain when it comes. I will explain. Just now refreshing the basic topics. So whenever if you are mixing different data types, okay, error message will occur. Okay, so suppose if computer does not understand, it will tell you need to write a command you need to write a command for an error message. Okay, so two type of error messages are there. One is based upon the syntax, and based upon the semantics. So syntax is equivalent to grammar. Syntax is equivalent to grammar, where semantics is equivalent to logic. Okay, your computer only able to understand the syntax error, your computer not able to understand the logical error. The logical error happening at how you understand that problem and how you develop that code for that. Okay, so for an example, the problem is about adding a plus b, but if you write a program to do a minus b, your computer cannot recognize a minus b is a wrong logic. Okay, so it only identify any syntax error, not about logical error. This is an example. So what we supposed to do? We supposed to add a string with an integer. Python doesn't know what will do, what it need to do. So this is an type error. Suppose if you are mixing two different data types, you should be very cautious. Okay. Same way. So if you try to minus hello from world, it doesn't know what to do. Suppose if you are giving plus, it will understand it is a concatenation. But if you are giving minus, it does not understand. So while learning a programming languages, what you're supposed to know, you need to know about the data type. You need to know about the strength of it, the strength of your data type, like specifications. Okay, so how much memory size you can allocate for the data type? Okay, what are the ranges it will cover? You need to know all this stuff, and what are the operations you are able to do over the data type. So all this stuff you need to know. Take an example of Boolean. Okay, suppose if you want to express something in true or false logic. Okay, so it is named after George Boolean, famous mathematician. George Boolean is the main pillar about Boolean algebra. Because of Boolean algebra, we are able to use computer in efficiently. Okay, so before computer, all this concept came from mathematics. So that is why I pinpointed in the first slide. So most of the aspects, computational aspects, came from mathematics. Okay, so Boolean value could be true or false, yes or no. Okay, height or tall, something. If you are able to classify in two levels, then you can say to be a Boolean. So Boolean is nothing but it will store only two-level logic. Two-level logic, logical value. Okay, so distinguishedly only two levels. So I will explain true or false, yes or no. Okay, so you can say black or white. So something is opposite and contrast, you can represent with the help of Boolean. So what is the use of Boolean? Easily we can do comparison. Okay, so directly you can do true or false, or you can do comparison with the help of this operator. So this is greater than, this is less than, right? Likewise, you can use less than or equal to, or greater than or equal to. Likewise, you can do a comparison. So most of the time, all these operations are built in, and you can access the operation through functions. Okay, so just like a scientific calculator, so many operations are built in. Exactly, plus 5 and minus 5. I want to skip that because of some reason, right? So you can use that function through function in Python. Okay, so when compared to all these programming languages, Python have very wonderful library of functions. Because of that, most of the people turn into Python. Okay. Suppose if you don't know, you can get through a function which is called type. So type, inside this type, if you give any value, it will return what is the data type it belongs to. Okay. Suppose sometimes if you don't know what data type you need to declare, you can recheck with your Python. You will give some value inside some brackets. Then you give that function type. It will automatically convert. Suppose if you are in middle of some operation, you need to convert one data type into another data type, then you can do typecasting. So typecasting is converting one data type into another data type. Okay. For an example, if you want to convert a numerical 42, a integer 42, okay, you can convert with the help of string 42, then it is converted in the form of text. Now, if you store 42 within double quotes, you cannot use for numerical operation. You cannot use for numerical operation because it is declared as text or converted as text. So this difference you need to identify. Okay. So look at here. Here integer is numerical, 3.14 is also numerical. But what we are doing, we are converting a floating point value into integer. So we are omitting this fractional part with the help of integer function. Okay. So today you go and try a little bit of this basic stuff in Python. So typecasting is mainly useful for converting values to and fro from strings. Most of the time we are converting value from strings to this. And this is an example for interpreter. So this is for short task. Okay. Files are for long task. So interpreter will immediately give output over here. So here you can write your program. Here you can write your program. Here you can observe your output. Here you can observe your output. So this is recommended for a small number of lines. If you want to execute 100 number of lines, if you want to execute 100 number of lines, better go for file operations. If you want to store in the form of file, the extension is .py. So this is file extension. So if you already know MS Word, the file extension is .docx. Okay. For PowerPoint, everybody of us know .ppt. In the same way, if you are writing any Python file, the extension will be .py. This is very easiest topic to print function. Most of us know. Okay, to print function. Okay, we need to use just print function. So print. So whatever you are giving inside, it will display. Right. So here interesting topic is print is a function. Inside we are giving some input. And what is the input we are giving? 4 minus 2. So it will do operation. It will do operation. Okay. So what is the operation? 4 minus 2. The answer is 2. That answer is get displayed in your interpreter. So sometimes you can use it for printing some value, or you can do some computation in print function also. So this is one good takeaway. So the next line you can see print 15 minus 110. Okay. But within double quotes means it is a text. Text means it will not do any operation. So no operation is performed over here. It will just display as it is. It will just display as it is. Okay. What about minus? See, whatever you are giving within double quotes, the entire part is considered like text. The entire part. the entire part. So here it is one operand, operand 1. Here it is one operand 1. So this is one operator. Okay, but if we give within double quotes, everything considered like text. So relate to the previous slide, you are able to understand. We discussed about strings, right, sir? Strings. Okay, so if you are giving strings, it is considered like a particular word. It is considered like particular word. It does not have meaning of any number or any numerical operator. We'll do some demo. Don't worry, we'll do some demo. Okay, to do all this stuff, we need to store separate variables. So variable will allow to save our data in the programming. Okay, how we are using files and folders in our computer, in the same way, variables you can consider like a storage compartment. Okay, so we can use for future computation also. We can use it for live computation also. So variable is just like name. Okay, every one of us have name, just like variables have a separate name. During a demo, I'll show all this stuff. Don't worry about that. So normally in programming languages, variable always come with equal sign because you need to store a particular value. Okay, so this is how it will get done. So variable in left side, value in right side. Okay, so whatever you are giving in right side, that is assigned to variable. Assigned to variable. Okay, so if you have pen and paper, if you are from non-CS and IT, please take a note. It will help you. So if you want to store any value in your program, okay, you need to use variable. So for an example, x equal to 5 plus 2. So what we are doing? So we are doing some operation 5 plus 2. The result is 6. Sorry, the result is 7. That value is stored in 7 right now. Okay, here it will do operation as well as it will store value in x. The next one is easy. So this is computation followed by assignment. Okay, so line number 2, dog equal to double quote Stella, and we are closing with double quote. It means it is a text. It is a text. This text is stored over dog variable. So imagine in this way. Here no computation is taken place, just storing a value in a particular variable. So sometimes assignment will come along with direct storage. Sometimes after computation, it will store your value. So you need to understand this difference. The next topic is about object-oriented programming. Object-oriented programming is different paradigm from general computation programming. So if you working in C, that is flat architecture, flat programming. If you are working in C++, it belongs to object-oriented. Okay, so you can consider C++, Java, Python. So all these languages belongs to object-oriented. Okay, the difference is very simple. When you look object-oriented programming, it will look everything in the form of object rather than function and logic. Okay, so function and logic is common for all programming languages, but particularly in object-oriented programming, you're looking everything like an object, a real-world object. Okay, so in short form, they will call OOPS. Sometimes OOPS they will call. So OOPS enhance coding part by doing modularity, maintainability, and usability. So these three topics we already discussed in first two or three slides. So if you are developing any project, it should be modular, it should be maintainable, it should be reusable. To do this, object-oriented programming will help you in much more easiest way when compared to C. Okay, so we'll look key principles of OOPS. Okay, key principles involved with encapsulation, inheritance, polymorphism, abstraction. I try to keep all this definition as easy as much as easy. The first one is about encapsulation. It is about bundling data and methods that operate on the data into a single unit while restricting direct access to internal details. So look at the image if you are not able to understand from text. So what we are doing, okay, we try to combine the variables. We already discussed the variables and methods, which is nothing but functions. Functions in C we call as function. In C++ we call it as methods, or in Java we call it as methods. If you combine these together, if you make a single entity, that is called class. So this process is called encapsulation. Okay, so if you're combining all this stuff, you no need to know what about the internal details, and you are able to restrict the direct access. Okay, the next topic is about inheritance. So it is like a mechanism. Already we know inheritance. It is like a heritage. We have father, mother, and we evolve from father and mother, right? In the same way, in programming, object-oriented programming, one class is there, which is called child class, derives property and behavior from another class called parent class, and promoting code reuse and hierarchical organization. So it is an example. Suppose if we created a class A, okay, what are all the properties of class A? You are able to directly inherit from this to class B. It is an example. Suppose if you are creating a class called vehicle, so vehicle is very general. Okay, it could contain fuel amount, it could contain capacity, what is the CC, it will have a brake. Okay, then you can build the same class for different vehicle. You can create a bus based upon these properties, functions. You can create car based upon the previous vehicle. You can create truck based upon the previous vehicle class. So just like our family hierarchy, right? So what are the property of your father and mother? You have the both combination, okay? But it will not go in reverse order, okay? What are the property the class bus contains? All the property doesn't have inherited by class vehicle. So only top to bottom is possible. Bottom to top is not possible, because here you have some specifications or specializations. So you can consider in this way. Okay, so bus is somewhat big. Bus contains driver seat, passenger seat. Okay, so it contains staircase. Okay, car doesn't have all the properties of bus, but some properties of bus. Okay, which is common to all this stuff. Definitely class vehicle contains all this stuff. So this is a real time example. So the general class is animal. Okay, from animal you can derive dog, cat, even you can go further, lion, tiger from cat. Okay, so basically everything from a general class, base class, you can say base class. The next important topic is about polymorphism. So polymorphism is the ability to use the same method name for different implementation and allowing flexible and scalable code. So for an example, The same person could act like a student, could act like a businessman, can act like a salesperson, can act like a negotiator, can take place in meeting, can go for shopping, can be part of a family. Okay, the same person shows multiple functionalities. Same way, the same code can transform into multiple functionalities. So we are wearing different caps according to the situation, right? Just now you are wearing the learner cap, I am wearing the trainer cap. Suppose if you go to home, you will act like a parent. Okay, so the same concept we are using in programming. And this is about abstraction, we already discussed. So abstraction is about hiding all unnecessary details, showing what is very important for the user. Okay, suppose if you are a beginner, if you are a beginner for a car, if you are learning how to drive a car, you know only about the steering, only know about clutch, brake, and gear system. Okay, you don't know about internal mechanism of your car. Okay, suppose if there is a breakdown, if you don't have any experience, then you cannot do anything about that. Okay, so abstraction will give a power for the developer, what should be showcased, what should be hidden during the programming. So if you understand all this stuff, then we can understand classes and objects. So class will act like a blueprint for creating objects. It defines attributes, which is the data. Okay, this is our input data, and methods, functions that operate on the data. So whatever you are having input, you need to define like an attribute, and you need to pass through a class. And this class contains some methods and function which will operate over the data to produce some output. Okay, so an object is an instance of a class that has its own unique value for the attribute defined in the class. So we'll go by some picture. Okay, so read the sentence of class and object. So class contains attributes and functionality. Okay, what could be an attribute for a person? Name, age, gender, occupation. What that person can do, that person can walk, eat, sleep, work. These are the functionalities. Okay, so we need to segregate our data, our object into this perspective. So this is a key concept about object-oriented programming, right? So once you declared what class contains, then you can go for object. So look at an example. We know a car class. So car class is very, very common. Okay, car contains 4 wheels, which is common for all cars. Car contains 2 headlights in front, 2 rear lights in back, so which is common. But based upon that, you can add a different derivations. Okay, so Maruti belongs to class car, Audi belongs to car class, BMW belongs to car class, but you are modifying all these attributes. You are modifying all these attributes. That is why object has specifications, having unique values, right? So basically, you can say class, from class, we are deriving object, which is a copy of it. Copy of it. That is called instance. So what is the meaning of instance? Which is a copy. So whatever the class contains, object contains each and everything. Okay. So this is a simple Python example, what we discussed in previous slide. Okay. Here I try to change color into yellow. So here class, and what we are defining a student. So student is a person. So in Python, we consider student as an class, as an object. You can imagine like an object. Okay. So what students will contain? Students will contain name and branch, which is very common for all. Okay. To define that, we need to define some functions. So this is your function name. This is your function name. Okay. Init means initialization. Initially, it will call by itself. It will call by itself. And what we are passing? We are passing name and branch, which is called input. Which is called input, or you can say attribute, or you can say parameter. Okay, so all these things are synonymous. Okay, so to declare a student, what we supposed to have? We supposed to have the student name and which branch he belongs to. So whatever you are giving input, that will come under over here. The name is assigned to name. Okay, here the self is reflecting student. Here the self is reflecting student. So what it means, once you created a class, so class contains two variables. Okay, name and branch. So whatever you are giving input, that input is stored over here. That input is stored over here. You can imagine in this way. Okay, so we already discussed. Okay, the class contains variables and functions. The second function is about display. You need to display the particular information about the student. Okay, so here there is no input. Whenever the display function is called, it will call by itself and it will return student self name branch. It means we'll get output in this way. Student, which is given by some name called Ravi. Okay, branch, which is some name given by IT. So it will display in this way. So this is what we happened over here. Okay, so look at line number 9. Look at line number 9. So here what we are doing, we are creating an object from student. So student, we are passing two parameters, R1 and IT. This is considered like input. So R1 is passed over here, IT is passed over here. So R1 is stored over here, IT is stored over here. So whenever you call this function, it is automatically displayed. So this is called function call. This is called function call. Okay, so what happened? Yeah, object is created over here. So here it is a student. Student one is called object. We created one object successfully from class. So this is class, this is object. So I hope everybody able to follow. Okay, so class contains basic definition. Object is a instance of a class or copy of a class. So I'll share this slide. You can go to Python interpreter, you can work on and you are able to see the output. Very, very easy for you. So this is how you will get output. So you can look downside. So student colon R1 branch IT. Okay. So classes are static structure. So if you declare class, it is like declaration, but objects are memory consuming entities. So whenever you created any object, you derive object, then only it will consume memory. Okay. While creating a class, it does not consume any memory. It is in your program. But if you create any object, it will access your system memory. Because we need to store something. Okay, to store something we need to access memory. Okay, as the number of object instance increases, so does the memory consumption, since the only attribute defined in the class contribute to the memory footprint of each instance. So whenever, wait a second, my slides are not able to, okay. Yes. So whenever you create an object, you should be conscious. If you created multiple objects in your loop, it will consume much more memory. Okay, this is what you need to take care. As a good programmer, you need to know if you do certain operation, what will happen in the backend or scenario. We already discussed encapsulation. So it is a technique of restricting direct access to object attribute and method while providing a controlled access. So this is very important, right? Suppose we have data, some data are very, very sensitive. Some data value should not get changed. During that time, we need to put some control access. Okay, it will prevent the accidental modification and it will enhance security. So if you know encapsulation properly, you can safeguard your data. Okay, you can do in multiple ways. You can put public attributes like public archives. So anybody in a city, they can go for library. Okay, if protected attribute means in library also they have some private section. Some enablers are able to go and visit over there. If you have some library card, then only you are able to lend. And private, you need to have some special privileges on particular occasion. So public attributes, as we discussed in previous slide, accessible from anywhere in your program. So if you are running your program, that private attributes could be accessed by anywhere. Protected, prefix with single underscore, should not get accessed outside of the class, but still accessible if necessary. Okay, protected means you need to have some privileges. Then only you are able to access that value. Private means you need to have prefix with double underscore and it will prevent direct access outside from the class, which will equally enforce encapsulation. Already they gave topic. I'll share this slide. Okay, here there is an important concept. Python does not enforce strict access control like Java and C++. Suppose if you are learning multiple languages, always do some comparison about this attribute access. For quantum, you need not to know too much. Basic is more than enough. But for other IT and CS, they need to know strict access control. And this is an example for access modifiers. So what I am discussing over public, private attribute, there is a sample coding is given over there. I'll share this slide always with the code. You can execute after some point of time. Maybe I will give some highlight. So this is bank account. I'll change my color. This is bank account. Okay, so this is a class. Class contains four function definitions. So each and every function definition contains some variable. So how many variables this contain? This contain two variables, and this contain the same variable like balance, and this contain comparison about computation, balance. So how many variables we have? We have 1, 2, 3 variables. 3 variables. So what are the 3 variables? You just check account holder, then we have balance, then we have amount. Okay, so how many functions we contain? Initial functions. Okay, then deposit, withdraw, get balance. So when a code is given, you need to understand what are the components you can segregate. You can study programming in reverse engineering. Okay, so this is very good way to learn any computer science program. Okay, you can do reverse engineering. So we already discussed, this is the function definition. Function definition contains 3 parameters. So line number 3 is assignment statement. Line number 3 is called assignment statement or expression, whatever you can say. So what we are doing assignment, we are storing account holder value into account holder variable. Okay, so this variable belongs to bank account. So this variable belongs to bank account. That is why we mention self dot account holder. Okay, so this variable is outside. This is given as input from the program outside of this class, which is given as input data. So this is the basic difference you need to know, right? So we got 2 inputs, we stored in variable, then we are getting amount. That amount is added with the balance. Okay, here you can check with plus equal. So I will explain with simple example. A equal to B plus C. So this is a simple C code. Okay, so what you can do, you can put in short form. Right? So A equal to A plus 5, and you can put A plus equal to 5. So I will erase this, it will confuse you. So this is shorthand notation, just like shorthand in the over days we have shorthand, right, to write something, to take notes. So this is shorthand notation. So instead of writing A equal to A plus 5, you can write A plus equal to 5. So in the same way, you can put balance equal to balance plus amount. So here what we are doing, after adding balance, remaining amount to the balance, we are checking whether amount is less than or equal to balance, right? If it is less than, then we need to reduce. Okay, when you do withdraw, what happens? You need to deduct from your balance. Okay, suppose if you don't have enough balance, then you need to write error message. Or you can write warning or information. So this is not actual error. This is an information about the account status. Sometimes you need to write your own logic in this way. All right. So suppose if you want to check balance, you need to write get balance function. So this is about get balance function. To understand this, what we are doing, we are creating an object. So bank account is the class. From the class, we are creating a variable, okay, an object, account. Okay, so 2 inputs are passed to account. So one is the account and one is the balance. So check your previous slide. Okay, so alias is the account holder. Okay, 1000 is the amount. So what you can do, you can print the account holder name. Okay, account holder will fetch alias. So this is the output. You will get alias over here. Then what you can do, you can access the account balance. So you can execute your code in this way. Okay, so bank account is the class. For the class, you are passing 2 parameters. It will create an object. Okay, for object you are associating 3 properties. Okay, one it will give alias, one it will give the balance amount. The third is also getting the same value, balance. So multiple ways you can access the same value by multiple functions. So if time permits, I will show basic demo about Python. I'll share this link in chat box. So please go. Can anybody please message? I can check. Yes. So go to this link. So many Python interpreters available in online. So already they gave a sample input for you. So what you can do, you can just run this code. So I try to explain this code first. So look at line number 4. We are creating a function def sum a comma b. It means it contains two parameters, right? Colon is the statement of this function. Okay. After this colon, function definition will come. Okay. So line number 5, what we are doing, we are returning. What we are returning? We are returning the summation of a plus b. Okay, simple. We are getting two inputs for this function and we are doing addition operation. We are returning that value. Okay, so line number 7, what we are doing, we are creating a variable called a equal to int, input, enter first number. So enter first number is text. So how we know it is a text? Because of single quote. We already discussed about how to declare a text by using a single text. Okay, so these parentheses will help to execute input function. So look at this input function. This input function will execute this statement, enter first number in your output. Okay, so whatever you give, that is taken from this input function. Okay, that input is converted into integer. So this is called typecasting. Okay, this whole part is called typecasting. Okay, whatever the value you gave, that is converted into integer. That integer value is stored in A. So the same way the line number 8 also perform. Okay, line number 10, what we are doing, we are using print statement. So print statement, what we are doing, we are printing sum of A and B is sum of A comma B. So here sum A comma B is called function call. So this is called function call. Okay, so I try to execute and I'll show how it is executing. So what is the first number? We can give any number as first. So I will give 3. Okay, so we need to scroll down. Scroll down a little bit. You can see the second line. So once you give the second line 2, then if you press enter, you gave 2 input. You gave 2 input. You gave 2 input. So come over here. Yes. So what is the value you gave? A equal to 3. B equal to 2. So this is passed over here. 3, 2. And what we are doing? A plus B. So 3 plus 2 is happened over here. The result is 5. That 5 is returned over here. So where it will return? Over here. So 5. So that is how you got your output over here. So I need to always trace from variable to where your computation get done. Yeah, I got one message. Printf only for C, sir. In Python only print. In Python only print. Int is for converting. Int is for converting. Suppose if you are giving over here, it is considered like text. Text is converted into integer. Okay. So what you can do, you can delete this line, give a equal to 3, put type of a. Okay, we need to use print type a. Class int. So I'll share this code. You check with this online interpreter. Otherwise, you need to install IDE in your system. IDE. So here you can execute one by one. So a equal to 3. Once I entered, you can show the output. Type of a. See, this is different. So I'll tell how to download this Python shell. Python IDE. You put download, it will lead to Python web page. So whenever if you download any software, make sure you are downloading from authentic and official website. Otherwise, sometimes malware will be there, right? So go to this website, download Python install manager. The latest version is Python 3.14.0. So always try to use the latest version. You can use anything. You can use anything. Each and every tool will operate in a little different way. Okay. So next what I will do, I will give the same input a single quote 3. Now if I check type a, it will give different results. I'll share this code. So here online IDE, you need to give in print statement. That is the only difference. Yeah, all of you able to run, execute? So that's all about today's class. Today's class is very, very tough because all these entire course compressed in single 2 hour, very difficult. So this is my social media ID. If you want to connect with me, you can connect. If you want to follow, you can follow. So I try to keep it is very simple as much as possible because multiple domain persons are involved in this program. Thank you all.
Thank you so much, sir. Thank you, Dr. Jay Kumar, sir. And participants, if you have any question or queries, you may put it in the chat box. And I hope Phyllis sir is also there. So, so participants, if you have any question or queries, or if you want some discussion, you may ask sir directly in the chat box.
So the topic is 4 different entire courses. Each course will take 1 semester. We try to cover within 2 hours.
Exactly. Yes. Yeah, actually, last time also Dr. Jaikma took this lecture, so it was that's how the compressed within just giving an overview. Everything also covered also. You cannot say that we did not touch or we have not covered. So most of the things are clear. It's a brush up. For those who are not into programming, I think you must read through some books also and follow. Maybe I would all advise all of you to look at Python coding. Very easy, very simple tutorials are there. Very easily you can pick up. Once you know one programming language, picking up Python is very easy. So absolutely no problem. So that's what. Yeah, few questions are there, I think. Yeah, material will be shared. We will share the slides. Sir always gives slides and also the notebooks that Jupyter notebooks that he creates for the coding. So they will be there. How to test quantum algorithms and can we cover testing algorithms? I think these are 2 questions. How to identify that given problem can be solved using quantum computing? 3 questions. Yeah.
We will cover in subsequent topics. During that time, you will get to know.
Right. So I think Python will be better. Python installation, just go to Google, you will get help on Python installation.
I will give one suggestion. Ask your students, they will know better. Nowadays, students, they are starting from school, they know Python better than faculties. So they will teach you. So give like an assignment, teach me this concept, they will do better job. Have personal assistant from students.
Yeah. Some of you are from degree colleges and from non-science background also. I understand that may be the struggle. So you can look at that. So in C language, printf is used. In Python, print is used. So f is not used in Python. So that's what he was emphasizing. So maybe you should look up a simple tutorial on Python. I think Vikas or myself will try to put up, if possible, we'll try to just share some material on Python, right?
Yes.
So
we have W3 schools. You may go through this online resources, very much helpful.
Right.
So
you can share the link, Vikas.
Definitely, sir. I will share.
We will share a few programs also, sir. With the description, we will share. They
Right,
can
right.
execute.
Slowly that assignments will be given, so don't worry. What are the softwares that need to be installed is basically, as we look at, if you have not joined QT-02, I'll request you to go through the previous lecture videos. I have already shared in QT-02 group and QT-03 group. I will put them again. So go through the 3 videos which were covered. Sir had covered Cascade, Penny Lane, Q inverse, and CIRQ, right? All these things were covered. So you can go through it once. Those are the things that are required, and most of them are open source and very easy to set up. I don't think there will be any issue, right? Yeah. So anyway, again, those things will be repeated. So briefly, he will revise that, and at that time also you can look at. But for to save time, you can go through that so that you'll be ready. Please, 3 videos of 2 hours each are there. We have identified. Vikasji, you can share that again so that
Yes, sir.
you can take it forward. Right?
Yes, sir.
Okay, sir. Thank you so much for your time.
Thank you,
And
sir.
tomorrow we'll meet at 3 o'clock. And there's a long journey this time, not only 20 days, it will be almost 29-day journey. So let us look forward, and it started well. So let us hopefully take it forward. Thank you so much.
Thank you, sir. Thank you.
Thank you so much, everyone. Yeah, we'll all meet at tomorrow, 3 o'clock. Thank you.